Hey guys, welcome back to Eureka, and in this video we're going to be continuing the mechanics basic questions, chapter number 2. Let's start with basic question number 1. State the difference between the length of the path and the displacement. If we have a point P and it goes from here to here, then to here, this is 5, this is 4, and this is 2, the distance is just going to be 5 plus 4 plus 2. It's the sum of all of the lengths, but your displacement is this, PQ, right? Because final minus initial. So if this is 3, then your displacement is just 3 PQ. It went from P to Q. That's the difference between displacement and distance. B. A particle P is moving on a straight line from point A, position 8. So you have P, which is at 8 meters. And then it moves to x2, which is at minus 4 meters. They're telling you find the displacement and find the length of the path. So the length of the path is 12 meters, right? Between 8 and minus 4, you have 12 meters. But your displacement is 12 meters in the minus sense, in the negative sense, because it goes backwards, right? That's it. In what sense is displacement? Backwards, because we have a negative sign. Next question. Basic question number 2. A particle P moves on a straight line. At time equals 1, you have its position. At time equals 2, it has its position. At time 3, has its position. They're telling you find the average speed. Speed is just distance over time, right? So let's find the time. The time is just going to be the final time minus the initial time. But the distance is going to be the sum of all of the distances, right? Or the sum of all of the lines. So we know that at x1 it's 8 meters. And then it moves to x2, which is at minus 2. So between 8 and minus 2, we have 10 meters, right? And then it goes from minus 2 to 2 meters. Between them, that's 4, right? So it's going to be 14 over 9. This is going to be 12, this is going to be 3, right? 14 over 9 is 1.6 almost, right? Your velocity, now let's find the velocity, the average velocity. Average velocity is displacement over time. Your displacement is final position minus initial position over final time minus initial time, right? By definition. So x3 is 2, x1 is 8. Difference in time is 9 seconds, so you get minus 6 over 9. That's your answer. See, pretty simple. The exam is not hard. Let's continue. Basic question number 3. At an instance t taken as a reference, you have two cars A and B and they're moving in opposite directions. They both have the same velocity, but since they're moving in opposite directions, one of them is going to be negative, right? And you have an observer, which is here. This is the observer. Observer. A is observed at 10 meters from the observer. B is at 100 meters from the observer. A is moving forward at 25 meters per second. B is moving backwards at 25 meters per second, right? So if we were to find, and they're moving at constant velocity. The question said constant velocity. So if we were to find the final position of A, we know that x final is just equal to 25t plus 10, right? And we know that x final of B is equal to minus 25t plus 100. Constant velocity, x final is equal to x initial plus vt, right? So we did part B, we did part C, and we explained part A. They're telling you in part D, they're telling you determine the time at which A and B meet. If A and B meet, their final position is the same, right? Because if A is going in this direction and B is going in this direction, they will meet at a point. That point will have the same position, or same final position. That means, what just happened? That means x final of A is equal to x final of B, right? So let's substitute the formulas. 25t plus 10 is equal to minus 25t plus 100. Let's solve this. We get that time is equal to 90 over 50, which is 9 over 5. See, it's pretty simple. We found the time. Part E, they're telling you determine the position of the two cars. So if we found the time, and we know that the positions are equal, we can substitute the time into any of the equations and we should get the same number, right? So let's substitute it into the first equation. And we get 55 meters. So the two objects, A and B, the two cars, they meet at 55 meters. And just to prove it to you, if you were to substitute it into the second equation, you're still going to get the same answer. And this is equal to 100 minus 45, which is 55 meters. Because the two objects crashed, so they have the same position. Their equations are equal. At 9/5, they're equal. And there we go. Let's continue. Question 4. A body is moving with a constant velocity, and they give you the values. At time 1 is at 2 seconds. So time 1, 2 seconds. Position 1 is 8.4 seconds. Time 2 is 7 seconds. X2 minus 1.6 meters. Right? They're telling you find the equation of motion of the body. First of all, it moves at a constant velocity. So x final is equal to x initial plus vt, right? Now let's find v. We know that v in URM is just going to be x2 minus x1 over t2 minus t1. Let's substitute the numbers. You get minus 1.6 minus 8.4 over 5 seconds. Using a calculator, you're going to get, I believe you're supposed to get 10. Minus 10. So this is minus 2 meters per second. Your velocity is minus 2 meters per second. So your final position is minus 2. Let me rewrite this, sorry. Minus 2t plus xi, right? Now they're telling you find the equation of motion and find the velocity. We found the velocity. Now we need to find the equation of motion. All we're missing is x initial, right? Well, we know that at 2 seconds, we're at 8.4 meters. So if we substitute 2 seconds, our final position is supposed to be at 8.4. So let's substitute for xi. You get that xi is equal to 12.4 meters. And now we found the answer. Minus 2 plus 12.4. That's going to be our x final. And that's the equation of motion. Next question. Basic question number 5. Define average velocity and whatnot. I'm not going to define them because memorize them or watch our other videos explaining them. Part B. Explain how you can get the value of average velocity or instantaneous velocity from the xt graph. You have the xt graph, right? Let's say it looks like this. If we were to draw the tangent, we know that this is the instantaneous velocity, right? The tangent to the xt graph is the instantaneous velocity. In other words, the derivative of the xt graph is the instantaneous velocity. Now, if you have 2 points and you join them with a line, we call this the average velocity. How do we calculate the average velocity? Well, it's just x final minus x initial over t final minus t initial. That's how you calculate them. Average velocity is the slope of the secant. Instantaneous velocity is the slope of the tangent. Let's go to question number 6. Question number 6. A body moves along a straight line with a constant velocity of 4 in the negative sense. So your velocity is minus 4 meters per second. And they're telling you when the time is 5 seconds, your final position is at 10 meters. They want us to find the position when time is 10. So let's find it. Since it's a constant velocity, we know that x final is equal to x initial plus minus 4t, right? All we're missing is xi. Well, we know that when time is 5, final position is 10. So 10 is equal to minus 4 by 5 plus x initial. Solve for x initial, you get 30. 30 meters. So let's substitute. So yeah, this is our equation of motion. Now they're telling you find the displacement when the time is 10. When the time is 10, you get xi is equal to minus 40 plus 30. So minus 10 meters. And then they're telling you draw the xt graph. Well, we know that we start at 30 meters. That's our initial. And then we're going down. That was very, very weird. And then we're going down because our velocity is sloping downwards. And it's URM. In URM, it's a straight line. The graph is a straight line, right? That's literally how it looks. When the time is 10, we know that we meet at minus 10, right? When the time is 5, we know that our displacement is 10. That's how you draw the graph. Let's continue. Basic question number 7. Okay, I'm gonna solve it, but there's one problem. Part C of this question, I don't really know how to solve it, so forgive me. I'm just gonna do part A and part B. A car travels for 50 kilometers per hour for the first hour, 40 kilometers per hour for the second hour. What is the average speed? We know that the average speed is just distance over time. Our time is 2 hours, right? First hour and second hour, so 2 hours. Now we need to find the distance. So in the first hour, so you went at 50 kilometers per hour for 1 hour, right? So if you go at 50 kilometers per hour every single hour, in 1 hour you go at 50 kilometers. You go by 50 kilometers. And the second part you went 40 kilometers per hour for 1 hour, right? So you went for 40 kilometers. So your distance is 90 kilometers. So let's substitute 90 kilometers over 2 hours, 45 kilometers per hour. That's it. Part B. A car travels at 50 kilometers per hour for 100 kilometers, right? So here you traveled for 2 hours, right? If you're going 50 kilometers for 1 hour, so 100 kilometers would be 2 hours, right? 100 over 50. 40 kilometers per hour for 100 kilometers. That means you went for 2.5 hours, right? 100 over 40. So we know that the total distance is 200 kilometers. We know that the time is 4.5. That's your answer, 200 over 4.5. Part C I'm not going to do. Let's move on. Basic question 8. Let's solve it. The slope of the xt graph, I already explained this. If you have the xt graph, this color is not suiting me. If you have the xt graph, the slope of the xt graph, when they tell you slope of the xt graph, that just means the derivative. So the derivative or the slope of the xt graph, we already said that's the instantaneous velocity, right? And the slope of the vt graph, which means the derivative of the vt graph, think about it, v over t is acceleration, right? So this is v instantaneous, a instantaneous. So derivative of v with respect to time is just a instantaneous. Or in other words, the slope of the vt graph is instantaneous acceleration. Part C, the area under the vt graph. Let's say the vt graph looks like this, yeah? The area under it is called displacement. Why? Well, I can't really tell you why. Your level of math can't explain it. Just memorize it. Area under vt graph is displacement. Basic question number 9, refer to the book. So we're not going to solve it because the explanation is already in the book. Basic question number 10. A car moving along a straight line accelerates uniformly. If it accelerates uniformly, so it's UARM, right? So let's draw the graph. It goes from 25 meters per second to 45 meters per second, right? In 30 seconds. In 30 seconds. And then it keeps that motion constant. It keeps that velocity constant for 50 seconds. And then it decelerates until it stops. I said it decelerates until it stops in 22.5 seconds, right? They're telling us find the average velocity. Well, average velocity is equal to displacement over time. We know that the time is 102.5 seconds. We need the displacement. We know that the displacement is the area under the VT graph, right? So we just need to find the area. So now we have three shapes. We have this trapezoid. And then we have this rectangle right here. And then we have this triangle right here. So we need to find the area of all of these three and add them, right? We know that this is 50, 80 minus 30 is 50, and we know that the height is 45. So the area of the rectangle is 45 multiplied by 50. We know that the area of the trapezoid is small base, which is this one, plus the big base, which is this one, multiplied over 2 multiplied by the height, which is 30. And we know that the area of the triangle is just base by height over 2, right? So 45 over 2 multiplied by 22.5, right? Now let's solve using a calculator. 45 times 50. And now, if you add them up, all of these three areas, you get 3,806.25, right? So that's our total displacement. And our times 102.5 seconds. So yeah, this is our answer. I'm just inputting it into a calculator. We're supposed to get 37.13 approximately meters per second. There you go. That's how we solve the question. Moving along, you see the questions that say T and then some weird stuff, January 2004. Well, these are past paper questions, and I asked my grade 12 friend. He said that they're not going to come, so we're just going to skip them. Basic question 11. A particle starts from point A with a velocity of 3, so our initial velocity is 3. And it moves with a constant acceleration UARM, right? I'm going to emphasize. Is 0.5 meters per second squared, right? And then it moves, and then it reaches point B. When it reaches point B, it has a velocity of 5. So final velocity is 5, right? And then they're telling you find the displacement and find the time. Well, let's find the displacement. We have V initial, we have V final, we have A. So we can simply apply this formula, right? 2A delta x. So delta x is equal to this over 2A, right? All we have to do is just substitute the numbers. So 5 squared minus 3 squared over 2 multiplied by 0.5. I think this should give you like 16, but let me check on the calculator. Yeah, 16 meters. So we found the displacement. Now they're telling you find the time. Well, how do we find the time? We know that it's UARM. So we know that V final is equal to V initial plus AT, right? We know V final, we know V initial, we know A. So we can find the time. V final is 5, V initial is 3, acceleration is 0.5, and T is T. So we can find it. T equals 4. There we go, solved. Let's move along to the next question. Basic question 12. Yeah, give me a second. Let me erase all this. Basic question 12. A car accelerates uniformly on a straight road. It goes from 6 meters per second to 20 meters per second in 8 seconds, right? We know that this is UARM because it says accelerates uniformly. So our acceleration is just V initial minus V final over the time. In other words, our acceleration is going to be equal to 14 over 8, which is around 1.75. That's our acceleration. Let's continue reading. Modeling the car as a particle, find the distance traveled during this time and the acceleration. We found the acceleration. We need to find the distance traveled. Well, we know that sorry about that. We know that the distance traveled is equal to half AT squared plus V0t, right? T is given to be 8 seconds. A, we just found it. So we can find the answer. So half 1.75, sorry about that, multiplied by the time squared, which is 1.75. The time is 8, so 8 squared plus, oh my god, I'm running low on battery. Right, 6 multiplied by the time, which is 8. Using a calculator, you get that the displacement is 104 meters. Done. Found the answer. Let's move along. Next question. They're telling you, basic question 13. A stone is thrown straight up with an initial velocity of 8. So V initial is 8. And it's thrown straight up from the roof of the house. The house is 7.2 meters above, right? And it's thrown with an initial velocity of 8 meters per second, right? So obviously G is negative because you're throwing the stone up and the earth is pulling it down. So G is negative. So our equation of motion is V final is equal to minus 10t plus 8, right? 8t plus Vi. Let's read part A. They're telling you find the speed at which it hits the ground. So we want to find V final when it hits the ground. So when it hits the ground, that means its displacement is minus 7.2, right? Because our positive sense is up. So if it goes down, it's minus 7.2. And be careful, they asked for speed, not velocity. So if we find velocity to be negative, we're supposed to make it positive. So we know that delta x is equal to half at squared plus ut, right? We have delta x, we have a, let's find t. So minus 7.2 is equal to half minus 10 multiplied by t squared plus 8t. Using a calculator, you get that our time could be one of these two values, right? Using the quadratic formula. Now we're only going to take the positive value because time is positive, right? So time is positive. So this is going to be our answer over minus 10, right? The minus cancels out. You get 8 plus 4 radical 13 over 10. So our time is about 2.24 seconds using a calculator, right? So we found our time. Now we need to find the speed at which it falls, right? So V final is equal to minus 10t plus 8, right? If we substitute into the equation, we get V final to be minus 14.3, right? Or actually, let's just do it. 14.4 actually, but in the paper it says 14.3. Well, to be honest, it's a rounding error. It's from me because using rational numbers. Anyways, let's assume it's 14.3. Now we need to find speed. Speed is going to be 14.3, not minus, because speed is a scalar quantity. So let's continue. So we found the speed and we found the time. That's it. That's all they're asking us for. Let's move along. Next question. Basic question 15. It says, Mira cycles east 20 kilometers per hour with respect to the ground. Zaina cycles east at 25 kilometers per hour. So yeah, Zaina is going at 20 kilometers per hour with respect to the ground. Mira is going at 20 kilometers per hour with respect to the ground. Zaina is going at 25 kilometers with respect to the ground, and they're both going in the same direction. So if Zaina is going 25 kilometers and Mira is going 20 kilometers, they're telling you find the velocity of Zaina with respect to Mira. So if Mira is here and Zaina is here, if you take Mira as a reference, Zaina is going at plus 5 meters per second. Subtract them. 25 minus 20 is 20. But if you want the velocity of Mira with respect to Zaina, it's going to be minus 5. Because Mira would like, if you were to look at them, Mira would be going backwards if you made Zaina stop. Or if Zaina were to look behind her while she's on the bicycle, she wouldn't feel like she's moving. She'd just see Mira going backwards. So the velocity of Mira with respect to Zaina is minus 5, but the velocity of Zaina with respect to Mira is positive 5. So that question is done. There's no equation for this. Just use common sense. Yeah. Let's continue. Yes. Basic question. Part B. Part B tells you a bus is moving at 65 meters per second north, and Lena is a girl on the bus, and she runs towards north at 3 meters per second. Find the velocity of Lena with respect to the ground. The bus is moving with 65, and the girl is on the bus, and she's moving with 3. So with respect to the ground, she moves at 68. Her velocity is at 68 meters per second. And what will happen if she runs back by 3 kilometers per hour? So if she runs back, if she goes backwards, her velocity is just going to be 65 minus 3. So 62 with respect to the ground, you know? So 68 and 62. Next question, basic question 17. A driver of a car traveling on a motorway at 35 meters per second suddenly sees the traffic light and its estimated distance is 60 meters ahead. He immediately applies the brake and it causes a deceleration. So his acceleration is minus 6 meters per second, right? His initial velocity is 32 meters per second. And delta x is 60 meters, right? 60 meters. He immediately applies the brake. Now they're asking, can a collision be avoided? In order for a collision to be avoided, V final must be 0, right? So let's find V final. We know that V final squared minus V initial squared is equal to 2A delta x, right? We have V initial, we have 2, we have A, and we have delta x. So we can find V final, right? So V final is equal to the square root of 2A delta x plus V squared initial. Substitute in the numbers, you get that. So 2 times minus 6 times 60, and then we have 32 squared. So it's the square root of 304. So your final velocity is going to be 17.4. If your final velocity is 17.4, that means the car is still going even after he slammed the brakes. If the car is still going, then the crash will happen. So that means you can't avoid a crash, right? So yeah, that question is solved. But if the V final was 0, that means the car stopped. That means he avoided the collision. Now question 18. The car is moving with a speed of 24 meters per second. When the driver sees a red light ahead, he applies the brakes and stops in 36 meters. So delta x is 36. And V initial is 24, right? They're telling you sketch the speed time graph. Well, yeah, speed time graph, V against t. You're at 24, and it's negative and it's decreasing until you finally get to 0. That's how it looks. And then they're telling you find the time at which it took to come to rest. So we know that it's UARM, so V final is V initial plus AT, right? We can't use this equation, I'm sorry. What can we use? Let's see, what can we use? Let's think about it for a second. Well, we have the graph, don't we? They're telling us find the time. What do we know about displacement? Displacement is the area under the VT graph. That means this triangle is equal to 36. The area of the triangle is equal to 36. We know that the height is 24. We don't know the time. Over 2, and that's 36, right? So now we can find the time. Time is just equal to 36 multiplied by 2 over 24, which is equal to 3. And that's your answer. Time is 3 seconds. Let's go to C. They're telling you find the retardation. By the way, be careful. They told you find the retardation. It's going to be a positive value because retardation means deceleration. So the car is decelerating. We need to find the value of deceleration. So let's find it. Right. We know that delta x is equal to half AT squared plus V0t or VIT, right? We know that delta x is 36. We know that we don't know the acceleration. We know the time. We just found it. And we know that the initial velocity is 24. So we can basically find acceleration. I'm just plugging everything in. Okay. So our acceleration is minus 8. So our deceleration or our retardation is 8. Okay, that's it. In the question, if you look at the answer, they say that a is equal to -8. A means acceleration, so technically the answer is correct. But if they said deceleration, the answer is supposed to be 8. I told you, skip the T questions, they're not going to come. So let's do basic question 19 and let's do basic question 20. Basic question 19. A car is moving along a straight road at a constant speed of 18. At an instant when the car passes a lay-by, I'm guessing that means a parking, a motorcyclist leaves the lay-by starting from rest and moves with a constant acceleration of 2. Given that the motorcycle overtakes the car by t seconds after leaving the bay, calculate capital T. So let's see. I think I know how to solve this, I'm not sure. So a car passes by and it's at 18 meters per second, and then all of a sudden a motorcyclist speeds behind it, right? And he accelerates at 2 meters per second squared. That means every 2 seconds his speed is increasing. Now in order for him to catch up by the car, the moment he catches up by the car, it takes him capital T seconds. That means the capital T should be equal to 9 seconds. How do we know it's 9 seconds? Well, the car's speed is 18 and the guy is accelerating by 2. If the guy's accelerating by 2, he's going to reach the car after 9 seconds, right? Let's go to part B. The speed of the motorcyclist the instant he passes by the car. That means the car and the motorcyclist are on the same level now, right? So he has 18 meters per second, the car has 18 meters per second. The second he leaves the car, his speed is going to be 20 because he accelerates at 2 meters per second. There we go. I'm not sure about the question I just solved, to be honest. I'm not sure. But yeah, keep it in mind. On a straight road, a car accelerates uniformly from rest, reaching a speed of 45 in 20 seconds, right? So uniformly from rest, speed is 45 meters per second in 20 seconds. Sorry about that. In 20 seconds. So that means your acceleration is going to be 45 over 20, right? And then he maintains that speed for 40 seconds behind the truck. Then the car accelerates uniformly for 75 meters per second for 20. After maintaining that speed, the car is brought to a halt by deceleration. So what I'm going to do is I'm going to draw the graph for this. Okay? The VT graph. The car, it starts from rest, then it goes to 45 meters per second in 20 seconds, right? I might need to extend this. I might. So let's continue. In 20 seconds. Then he maintains that speed for 90 seconds. So he maintains that speed for 90 seconds, right? And then he accelerates to 75. Then he accelerates to 75 meters per second in a further of 20 seconds. So this is 130, right? And then he maintains that speed for 4 minutes. So if he maintains it for 4 minutes, well, time is going to be 370, right? And then I'm going to have to swipe here, actually. I need more space. And then the car is brought to a halt with a deceleration of 4. If he decelerates at 4, that means it takes him 18.75 seconds, right? So let's see. So the final time where he stops is going to be at 388.75. So here, 388.75, right? Part A, they're telling you find the total distance traveled. The total distance traveled is basically this whole area, right? I'm not going to find the whole area. You find it by yourself. It's simple math. And then they're telling you the total time taken. Well, here's the total time taken. And then they're telling you the average speed in the first 130. So the average speed is just going to be distance over time, right? So time is 130 and the distance is this whole area, We don't need this area because they said in the first 130. So you find the area of this whole object. Let's call it A. Actually, let's call it F. The answer is going to be F over 130. And then D, they're telling you find the average acceleration in the first 130. Well, what do we know about average acceleration? Average acceleration means V final minus V initial over delta time, over 130. So you went from 0 to 75 in 130. So I'm guessing your acceleration is 75 over 130. And there we go. We solved the basic questions. Thank you guys for watching, and as always, easy.